So in the previous lecture, we have started like a spring force. Now in this lecture, we will understand free body diagram, constant relation. So let us understand the free body diagram. First of all, you should understand how to draw the free body diagram. Write down the heading, free FBD, free body diagram, FBD, free body diagram. Yeah. Now how to draw free body diagram? For example, one block is there on this floor. One block is placed like this. First of all, write the definition. Okay. What is the free body diagram? First, write the definition. It is a diagram. It is a diagram which represent all forces with their direction. Clear? So it's a diagram which represent all forces with their direction. So in this diagram, we are basically drawing all the forces with their direction. Okay, not only magnitude, direction also. Clear?
Yes, sir.
Let us understand. This block is placed on the floor. If I consider this block is my system, like this. Okay. We are denoting this block by a point, single point, like this. Now on this block, there are two forces mainly. One is gravity, that is
Normal.
mg. One is normal reaction force. Okay. So all the forces I will draw here. One is mg, one is normal. Okay. Like this. This is the free body diagram. This is dot is m. The free body diagram of this block. Clear?
Yes, sir.
Similarly, if I ask like draw the free body diagram of this system on this floor, two blocks are placed like this. Okay, surface smooth. M1, M2. Okay. Now in this case, draw the free body diagram of M1 and M2. Please draw. First, draw the free body diagram of M1 and draw the free body diagram of M2. Please draw. I'm also drawing. Okay. First, you take M1 as system. M1 as system. Okay. Now on this M1, this M2. Remember one thing in the free body diagram, we are denoting all the forces that is acting on the system. Clear? We are not at all interested what is the forces within the system. Okay. We never draw
Yes,
all the internal forces. What forces are acting on that M1 due to other simple surrounding. Okay. Due to other elements, what are the forces acting on that? We are denoting that. What
sir.
force
For
is this
M1,
M1 block? What force is this M1
M1G,
block is going to act on other block? We are not going to draw. Clear? Yes, tell me.
sir.
Now,
M1G,
yes, very good. M1G. Gravity is applying.
normal force,
M1G.
sir.
Normal due to M2. Like this.
Yes, sir.
I can take N2. Any other forces? No.
Friction, sir. Can we take friction, sir? Here?
Friction? No. I just consider a smooth surface. Okay.
Yes, sir.
Okay, then how will you draw the free body diagram like this?
Dot
M1,
M.
M1G, N2. Okay.
Yes, sir.
Understood?
Yes, sir.
Similarly,
Understood.
draw the free body diagram of M2. Take this is your system now. Okay. This is your system. If this is your system now, draw all the forces acting on this M2 due to other. Clear? Don't draw any
Yes.
forces which is due to this M2 on other object. Now this is my system. Then my observation is that who is applying the force on that? Who is applying? M1?
M1
Normal?
is applying the force.
Very good. So on this, M1 is going to apply like this. N2. Okay. This the ground is going to apply normal like this. Okay. That is placed on the ground. And one gravity. Clear? Then how will
Yes,
you
sir.
show? Like this. This is M2.
M2G,
Okay.
M2
Very good. M2G.
downwards N2
Very good.
and upwards N3.
Very good. Clear? But
Yes,
if
sir.
I take like, see the same question is there. Same question. But now I'm taking M1, M2 as system. This is M1. Is it so like? Okay. M1 is above, M2 is down. No worry. Now if I take this is entire is my system. This is my system. Okay. Okay. Now on this system, who is going to apply the force?
Normal force, sir, and then gravity.
Very good. When I'm taking the system now, this block I'm drawing. It means that this is when I take this both as a system. It means that draw one block like this. Meaning is that okay.
Yes, sir.
Now draw all the forces. My system is this. Okay, one is M1 plus M2 into G. Okay, one is due to ground. You can take how much? N dash. Okay, understood?
Yes, sir,
Yeah.
understood.
Okay. I think this is clear to you. Now I will give you
Yes, sir.
one more like you draw. Please draw. In this case, draw the free body diagram. This is a wedge. On this wedge, like this. 1 minute. What is happening? This 1 minute. Some technical issue. Sorry. I just place one block. Okay. 1 minute. I just place one block like this. Okay. This block is having the mass m, and theta is the angle of inclination. Okay. Now please draw the free body diagram of this block. This is my system. Okay. Understood?
Yes, sir.
Please draw. So on this, how many forces are going to act? You just check. If you just tell me in which direction, if this block is having the acceleration, this block is moving like this. Okay. If it is going from top to down, then it will go like this. Clear? It will go like this.
Mm.
Now, one force will be like on this block, one is gravity. Gravity will act now. Clear? Gravity is down like this.
Yes, sir.
One is normal because the surface is in contact like this, perpendicular to surface. Okay. Understood?
Yes, sir.
This is
Understood.
90. Okay. This is theta. This is 90 minus theta. Okay.
Yes, sir.
If you drag this, can we drag like this? Like this. Okay.
Yes, sir.
Now you can check this is perpendicular. This total is 90 degree. Okay. Okay, like this. Then if I ask you like if this is 90 minus theta is theta, clear?
Yes,
Then
sir. Clear.
mg has two component. One is mg cos theta.
MG sin theta.
Very good. And mg cos theta is this. Then perpendicular to mg cos theta, there is one more component. That is mg
Sin theta.
like this. Mg sin theta. Very good. You can check both are perpendicular. Clear?
Yes, sir.
Now in this question, like or where you will take x and y, the x always take in the direction where. Now if you draw the free body diagram, you will draw like this separately, like okay, mg is that like this. Okay, then if you want to show like this is theta, this is theta. Okay, mg cos theta and mg sin theta. Okay, is it clear?
Sir, what about acceleration, sir?
I'm telling. Acceleration, I'm saying acceleration will be there. But what is my like what I want to try like understand. Okay, acceleration, I'm saying like for example, if a block is coming from top to down, clear? Understood? Not
Yes,
direction,
sir.
the
Understood.
direction in which the block is going to accelerate. Take x along that. Then here, like if block is going from top to down, now take x axis here. To make your calculation easy, I'm telling these steps. Always take in the direction of acceleration your x axis. Okay, and this is y axis like this. Always take like this. Okay, because you have to draw no x or y origin. Clear? X y. Where you will take x y, you will take like this. That is only I will suggest like. Understood? If your
Yes,
observer
sir.
is inertial, non-inertial frame, I will explain later. Now this is clear to you.
Yes, sir. It's clear to me.
Okay. Now I will ask you like if this block is placed like this. See, this is the wedge. Okay. If block is placed like this. Now did you see one thing like this block is having mass m. This is theta. Now draw the free body diagram. If you look at back, mg, if this theta, you can check mg sin theta will be here parallel to surface, and mg cos theta is perpendicular to normal. Clear? Then in this, like how will you draw? Like this. You will draw mg like this. Okay. mg cos theta is mg sin theta parallel to surface like this, and mg, this is what? mg cos theta. Okay, like this. And perpendicular to mg cos theta, normal is there. You can check previous. mg sin theta is parallel to the surface, inclined surface. Okay, and mg cos theta is anti-parallel to normal. Okay, like this. Clear?
Yes, sir.
Even if you want to check, this is theta. This is also like theta. Okay. You can do like, don't worry.
So I got it.
Clear? Same thing like, I'm not teaching anything advanced, okay? Same thing. Next, in numerical like this will help you. Like if I ask you like draw the free body diagram in this case, like this. This is a pulley. One string is there, like this. Two blocks. M1, M2. And this force is going to act like this. Please draw the free body diagram of all the blocks. First draw the free body diagram of M1, then M2, then M. Okay. Then first take M1 as system like this. Okay. Now draw free for like all the forces which is acting on the system. One is gravity. Okay. One, because string is tight, then tension will be there. And what is the direction of tension?
Upward, sir.
Very good. Upward. Very good. Clear? Now how you draw separately if you want to draw like this, you can draw M1G free body diagram like this. Separately I'm showing like this because it makes our calculation easier. Otherwise you will be confused. Other no worry. If you draw in the figure itself, no need to worry. If you understand. Now for M2, draw the free body diagram of M2. This is my system. So gravity will be there. M2G. One is normal, like N2. And tension will be where? The direction of tension is along the string and it is in that direction in which the string is going to attract the block. In which direction the string will attract this block? Tell me.
Right side.
Then tension will be like, in this direction it will attract like this. Okay. This
Yes,
tension
sir.
is T is a tension acting on this M2 block. Clear? Now how will you draw like separately? Like this. M2G. One is normal. One is tension like this. T. Okay. Similarly for this bigger block, that is this, draw the free body diagram. Take a system. Clear? Now draw. Since it is placed on the floor and it is hanging, okay. From the ground, one is like this, N3, Q2, M2, and because of this, one tension is like this. Okay. Clear? You can T1, you can take T1, okay? No worry. How will you draw? Like this. One is gravity also, okay? Here M into G. And one is like N3, N2, and one is like this tension. Clear? Understood?
Yes, sir.
Any doubt?
Yes, sir. Understood.
If you have any doubt, you can
No doubt,
ask any doubt,
sir.
okay?
Yes, sir.
Okay, you have drawn. Now next is
Yes,
like,
sir.
I think this is clear to you. Write down next topic is constraint relation. Write down constraint relation. This topic is very, very important. Like, write down the heading constraint relation. So constraint relation is of two types. One is visible constraint relation, one is calculative. Write down. It is of two types. One is visible relation, visible relation. One is calculation relation. Means after calculation we are deriving the result. Okay, calculation relation. For calculation relation, I will give you tricks. Okay, no need to worry. Calculation relation. Now write down about visible constant relation little bit. First write down visible. It is easy only. Like visible relation means with your eyes. If you look at the condition of visible relation, you can apply that. Okay. So write down visible. Write down the heading. Write down visible constant relation. Constant relation states that magnitude of acceleration magnitude of acceleration or magnitude of velocity magnitude of velocity of two bodies are same. Of two bodies are same. Only magnitude, okay? Direction I'm not saying. Of two bodies are same. If there are two conditions. If first condition write down. Both bodies are connected by the same string. Both bodies are connected by same string. Next, pulley over which string passes. Pulley over which string passes should be fixed. Should be fixed. Okay. Third, bodies move along a string. Third condition, bodies move along a string. These are the three conditions. Please write first.
Completed writing, sir.
Writing? Okay. So there are three conditions like first is bodies should be connected by the same string. First condition. Pulley should be fixed. It should not be movable. Third, body should move along a string. If these three conditions are valid, then we can say the magnitude of acceleration or magnitude of velocity of two bodies are same. Meaning is that, for example, just look at here. Meaning is that, for example, these two blocks. If I draw any two blocks like this is a question like, for example, this is the case. Here our pulley is that. This is a string. I'm drawing like this. One string is this. Okay. And one string is passing like this. Okay. Now these are connected by two blocks. It is having m1 mass. It is having m2 mass. m2 is greater than m1. I'm saying m2 is greater than m1. Okay. Now check the condition. First condition is both the blocks. Both the blocks are connected by the same string. You can check same string. Same string is there. Clear? Same string is there. Second condition like pulley should be fixed. Pulley over which the string passes, that should be fixed. You can check. Pulley is fixed. Pulley is fixed. Fix here. It is fixed support pulley. Clear? Pulley is fixed. Pulley is not moving. Okay. Fixed support pulley. Third condition, body should move along a string. Now, if M2 is heavier and M1 is lighter, then M2 is going down, M1 is going up. Then you can check that the direction of motion of the block is along the string. Clear? Now, in this case, we can say the acceleration, magnitude, or velocity is same. It means that if M2 is going down with A acceleration, because its mass is more, then M1 is going up with A acceleration. Their magnitude are same. A here, A here. Clear? But this is valid only when these two blocks are connected by the same
Equal.
string. Pulley should be fixed.
Same string and equal
And
magnitude.
body should move along a string. Clear? Understood?
Yes, sir.
That is very, very
Yes, sir.
important. Like
Understood.
body should move along a string. For example, this case. This is a pulley. One block is like this. And this is string. Okay, this string. This is second block. M2 here, M1. Clear? Now, in this case also, like if you ask me, sir, you can check. Both the blocks are connected by the same string. Pulley is fix from here, fix. Body is moving along a string. If this block is going down, then a string is also going down. Body move along a string. If this block is moving in the right direction, this string is also going in the right direction, then bodies are moving along a string. Then we can say, since M2 is higher, and weight of, like we can say, mass of M2 is higher than the mass of M1. If I say M2 is greater than M1, then M2 is going down. Okay, it is going down with A acceleration, then it is going in the right with the acceleration. I'm not saying direction is same, but the magnitude is same. If it is 4 meter per second square, it is also 4 meter per second square. Clear? Both the blocks are connected by the same string. Pulley should be fixed and body should move along a string. Clear? If these three conditions are valid, then we can say our job is finished. Clear? Is my voice audible? Hello? Hello? Second case, like if I ask, like in this case, if pulley is moving with a certain acceleration, let us suppose AP, like this. and both the blocks are connected by the same string. Clear? See, what I've explained, 1 minute. I will explain you. Now you can check like here also pulley is fixed and bodies are moving along a string. In second case, then you can check A acceleration here, A acceleration here. Clear? Both the blocks
Yes,
are
sir.
connected by the string. Pulley is fixed. Clear? Then we can say it is having the same acceleration. Both the blocks is having the same. This is visible relation. Okay. Most of the question, around 60% of the question in JEE Mains, you can go with a like visible constant relation. But they may ask like when pulley is movable like this. In this case, if I ask like 1 minute, if I ask in this case, for example, pulley is movable and these block, check the condition. These two blocks are connected by the same string. Okay. But here condition 2 is failed. Pulley is movable. AP is the acceleration of pulley. Here pulley is not fixed. So we can't say this block and this block is having the equal acceleration. Direction I'm not at all interested. I just want to say like magnitude of acceleration in this case of two blocks will not be same. Then if it is not same, then you can take any direction. If you take direction like this, A1, you can take A2 like this as per your convenience. A1 is the acceleration of first block, A2 is the acceleration of second block. Here visible constant relation is not valid. You can't say here like even M2 is more than M1. You can't say this block is going down, this block is going up. We are not sure where it will go because we don't know where is our observer. If you look at from the ground, then M1, M2, you can't sure where this block will move because now pulley is movable. It is not fixed. Clear? Understood?
Sir, I have a doubt, sir.
Yes, please ask.
Will the mass of the bodies affect the acceleration?
Will the mass? Yes. When you find the
Then,
A1, A2, when you like tension.
not in this particular case, sir. In visible constant relation.
Okay. You are saying like invisible constant relation will these mass M1, M2 will affect the A, obviously. I am saying magnitude are same. Clear?
Okay.
Magnitude are same, but its value depends on M1, M2 and tension. It depends. When we will solve numerical, okay. First, I just want to make you understand what is the meaning of these relation, okay. Next, like one important concept is that here a string which we have assumed here is the string is massless. What is the characteristics of the string? Characteristics, a string is massless. A string is massless. First of all, a string is massless. Massless means light. Okay, light string. Okay. Second,
Yes, sir.
inextensible. 90% of the question like you will find like this. Inextensible. Inextensible. Inextensible means what? Like this. If you take a light string like this, okay. If you take any 2 points inside the string, point A, point B, then if it is inextensible means what? The distance between these 2 points will not change. Inextensible means distance between A and B, DAB, is constant. Meaning is that. Understood? DAB is constant.
Yes, sir.
DAB constant means like you have a wire. For example, we will understand this DAB means this is any 2 points. If you take not only A and B, if you take any points inside the string, that distance between them will not change. Meaning is that inextensible means DAB should be constant. If it is 3 meter, it will remain 3 meter. Then only it is inextensible. Clear? Now, one example I have already, I think, given. So I just want to again, I just want to explain again. Just look at here. For example, this is one block. This block is having M1 mass, and this block is M2 mass. Clear? Okay. See what I am saying like that. Look at here. If these two blocks are connected by a string is massless. Then very, very important, if you are applying a force on this M2 block, let us suppose 20 Newton. 20 Newton. Then because of 20 Newton force, there is, if you draw, if I ask you like, if 20 Newton if you have applied, then these two blocks are getting a acceleration. What I am saying, like, if I say this is my string, okay, a string, and a string is massless and inextensible. I'm talking about this. Just see, look at here, very, very important, like, this is the end of the string, and this is the end of the string. You can take this end is B, this end is A. Clear? Now, if
Yes,
this
sir.
block is this M2 block, if this block is moving in the right with, for example, little bit it displace. Let us suppose dx. Clear? Dx displacement in the right direction. M2 block. Or you can say dxa. Clear? Dxa. Here B I have taken a dxb, you can take dxb. Clear? If this block is moving dxb amount, then this, clear? Similar here, like this A point is taking a displacement of dxa. Okay, when M1, M2 will move, this A and B point will move. Clear? I'm
Yes,
talking
sir.
what I'm saying, just understand. On this string, this string is going to apply, tension on this M2. In which direction? Like this. In this direction it will attract. Similarly, this string is going to apply, clear, tension on this M1 like this. Okay. Now when this string is going to apply tension on this M1 block, then only it is moving now, M1. The M1 is going to
Yes, sir.
move in the right direction because of this tension force. There is no other force which is responsible for this block M1 to move in the right direction. Clear? Now, if this A is displaced, if A displays dxa amount, if A displays A and B, A point this, B point this. If this A displays dxa amount in the right, then M1 will also displace dxa amount. Clear? Our concept is, in the previous lecture what we have discussed, the net work done by the string. Net work done by the string. Net work done by the string is 0. Clear? This is what we have learned. So net work done, how much work done by the string? Net work done by the string,
0.
clear, is 0. Now on this M2 block, how much work is done by the string? Force into displacement. Displacement of M2 is the displacement of ends, this end, minus, plus work done on this M1, how much? Force into displacement equal to 0. We can say T dxa minus dxb, okay, divide by dt. Okay. Now you just tell me, if this work done, net work done by this is VA na, VA minus VB. Okay. Understood? Now
Yes,
here,
sir.
like, if I ask like T into, you can check VA minus VB equal to 0. tension cannot be 0. Tension is not equal to 0. Then who will make this equation to be 0? LHS is equal to RHS when VA is equal to VB. Or we can say acceleration of A must be equal to the acceleration of B. This relation which we found now. How we find this relation? If two blocks are connected by the string, the net work done by the string is 0. From there, I find the relation. Clear? Net work done by the string is 0. Clear?
Yes, sir.
Are you understanding this?
Yes, sir. Understood.
Okay. Now this you should understand this simply. From here, what you find like, what is your observation like? T into VA minus VB. If you ask me like T into VA minus T into VB is equal to 0. Then T into VA is what? It is work na? Work done
Yes,
by the string on block A. Or we can say work done by the tension, work done by tension on M2 block. Okay. Sorry, A, you take M1. Clear? T into VB means what? T into VB more, this, what does it means like? Actually, it is work done by the string on M2. Clear? M2. So we can say net work done by the string on these two blocks will be 0. Or we can say net work done by the what? Net work done is 0. Net power supplied by the string is 0. Clear? Power formula is what? Actually, it is power. Okay. Power is what? If you ask me, power formula is what? Power is
energy by
work by time. And work is force into displacement. And displacement by time is what? Force into displacement by time is velocity. So in our case, force is tension, velocity. So tension into velocity is what? Power. Clear? So you can say, please look at here. Here tension into velocity is power. This is, we can say, power also. Clear?
yes, sir.
Understood? Power.
Yes, sir.
Either you can say work done by the string, net work done by the string is 0, or we can say net power supplied. There is no power transfer. Net power transfer by the string is 0. But individual power is not 0. Clear?
Yes,
Understood?
sir. Clear.
The next thing like, next thing. Now did you observe that one thing, VA is equal to VB. VA is equal to VB means what? Like this. What is the condition like? This M1, M2. Okay. VA is equal to VB. Which one is VA? I think this I have assumed this ends. This end of the string is, I think, VA or VB? A.
Yes, sir.
This end of the string is VB. Okay. It means that if this end is going with 2 meter per second in the right, then it should also move in with 2 meter per second in the right. Meaning is that clear? If you want the string to be inextensible, massless, inextensible, then all the particles of the string should move with 2 meter per second. Clear? If I say this A and B, these are the 2 points of the string. Ends. This is also point now. A and B is what?
Yes, sir.
A and B are the ends of the string, or you can say it is the points. There are 2 points in the string. I just take A and B. If A is going in the right with 2 meter per second, then B should move. B must move with 2 meter per second. Otherwise, there is extension in the string. Okay, this is correct. If you see like this, it means what? This 2 meter per second is what? It's the velocity along the string. What is 2 meter per second? Velocity along,
Velocity.
not velocity, you should say velocity in the direction of a string. Velocity along a string. I'm talking about velocity along a string. I'm not talking any other velocity. Okay. Velocity along a string must be same. Okay,
Yes, sir.
clear? So
Yes.
you can't say like, sir, it is 3 meter per second. It is 1 meter per second. It will not. Or it is 4 meter per second. It is wrong. Otherwise, what will happen? There is some extension will come in the string. Then our assumption is destroyed fully. We have assumed like our string is massless, inextensible. Then only this relation like it is correct. Clear?
Yes, sir.
Our string is applying tension on this M1 block. You can check. If you look at here, this M1 block is connected with a string with the help of this A point. Okay. With the help of this A point. And string is going to apply tension on this end. You can say either end on this M1. Because of this block is going to move in the right. Clear?
Yes, sir.
Now, if I ask you like this case, if I ask you this case, like this. Okay, like this. Clear? M1, M2. Clear? In this
Yes,
case,
sir.
you can take how many ends are here? For
Three.
one only. These two blocks are connected by this string. Okay, clear?
Yes, sir.
Then how many ends are here? One end this, one end of the string is here, one end is here, one is here. Okay, understood?
Yes, sir. Understood.
So ends you should understand like what are the ends? Starting end and free end. Like this is clear. If this is clear, like you have more clarity. Clear?
Yes, sir.
Next concept is just look at here. Look at here. This is the pulley, and this pulley is not fixed. There are two blocks. A string. These are the two blocks. M1, M2. Clear? Now look at here. This is X1. X1. From here to here, I just take X1 distance. This is X2. Okay. And this pulley is going with a certain acceleration above. Clear? Clear?
Yes, sir.
AP is the
Clear.
acceleration of pulley. Now from here to here, if I add like, can I say X1 plus X2 is equal to length of string L?
Sir, but
You
over
are
the pulley,
saying,
there wouldn't be.
and this is constant, na? It's never change. I already added this portion, na? Added in that. If you are saying like
Okay.
that also, like that will not change. We are only writing the variable length. Okay. If you are correctly, you are saying x1 plus x2 plus that top pi r is equal to L1. Then x1 plus L, okay. L1 you can say, okay. x1 plus then L minus. Okay. You can say like this also. L, no worry. It
Yes,
will be
sir.
cancelled out. Okay. See. Now, if you look at here, if you differentiate the both side, dx1 by dt, dx1 by dt, here also differentiate. String length is constant, pi r is constant, so it will be 0.
Yes, sir.
Clear? Now this dx1 by dt, it is what, look at this is very, very important. Like, what is this dx1 by dt? dx1 means rate of change of this length. x1
Rate
from
of
this, from here to here, this end and this end. This end is connected with a m1 and this end is connected with a pulley. Okay. If you check, this x1 is in between this end and this end, this point and this point. Clear? Now this point is lying on the pulley. Clear? So this rate of change of this x1 depends on what? This
pulley.
rate dx1 by dt, actually it is not a velocity of what? It is not a velocity of, you can't say like it is a velocity of m1. Clear? What I should say,
Yes,
what
sir.
is my observation? Look at here. This dx1 by dt. See, when this pulley is going with AP acceleration, then m1 is also going up. When m1 is going up, this point, look at this point. Then this point is also going up. Clear? We can't say like both are moving with the same velocity, same. We are not at all sure. If this is moving with AP acceleration, this is also going with AP because it is connected with the pulley. This end, it is also going with AP acceleration, and m1 is going with certain other acceleration, a1 or a2, whatever else. We are not at all sure. Then the dx1 by dt is the velocity of what? This m1 block with respect to pulley. Okay. Similarly,
Yes,
this is
sir.
velocity of m2 block with respect to pulley is equal to 0. Clear? If you differentiate again, you will get acceleration of m1 with respect to pulley plus acceleration of m2 with respect to pulley. Why am I writing with respect to pulley? Because this acceleration depends on pulley also. Clear? Because this end is going with pulley. Clear? Understood that
Yes,
this
sir.
dx1 by dt, it is what? It's a relative velocity. Clear? So here, like,
Yes, sir.
what is the observation? am1 p. How can you write like this? You can write am1 with respect to ground, apg. Can you write like this? Clear? Similarly, you can write am2p. How can you write like this? Like this. Okay. Clear? So
Yes,
once
sir.
you write these two equation here in equation 1, what you will get? Just put it here, am1g, am1 direct you can write minus ap, understood, okay? am2 minus ap equal to 0. So from here you can get acceleration of pulley will be what? Acceleration of m1 block, acceleration of m2 block divided by 2. Clear? This is a very, very important relation. Somebody is writing like this. They are considering acceleration of m1 block a1 plus a2 by 2 like this. That is also correct. No need to worry. Understood?
Yes, sir. Understood.
This is very, very important relation. Like, this is calculation relation. Just now I have derived now. This is calculation relation. After doing calculation, I am getting this. Okay. So here like pulley is also moving and M1 is also moving like this. Clear? Here pulley, if you look at me, this pulley is also moving and M1 is also moving like this. Both are moving. So this dx1, this change in the x1 with time depends on both pulley and what?
Acceleration.
If you directly, if pulley is fixed, then if pulley is fixed, if I say pulley is fixed, then this is zero. We can't say like if pulley is fixed, you can say directly, sir, the change in the x1 depends on the movement of m1 only. Okay, if pulley is fixed, then we can't say v m1p, velocity of m1 with respect to pulley. We can't say if pulley is fixed. Clear? But if pulley is not fixed, then its velocity, its acceleration depends on its a relative velocity. Clear? This change in dx1. Understood? M1, this is M1, this is two ends. Two ends. One end is lying on the pulley and this end is lying on the M1. And both are moving like this. Okay. Then this in between separation in between this point, like separation in between this point, let x1. Its rate of change of this separation, that is x1, depends on what? Clear? It depends on its a relative term. Clear? So if I
Yes,
say
sir.
like, so here what I'm saying like that, this is what like, clear? Velocity of m1 with respect to pulley. It means our observer is where? It is on the pulley. Clear? You can say like that. So x1 will vary. X1. The change in x1 depends on both. Understood?
Yes, sir.
Clear? Any doubt?
No doubt, sir.
Still you have doubt, you can ask me because you are going to, I will give you one numerical. Okay?
Yes, sir.
Okay, 1 minute. Actually, page finish. 1 minute. Actually, things are a little bit tough, but I can't. We can't skip tough things. Okay. One. 1 minute. Okay. Hmm. Write down one question. Write down. Write down the question. Find the acceleration of. Find the acceleration of given blocks. Okay. This is the case. 5 meter per second. Okay. One block is this. One block is this. Hmm. This is 1 kg block. This is 2 kg block. And in the question they have mentioned 1 kg block is going like this. Tell me. Okay. Velocity of pulley is given. Velocity of block is given. Find the velocity. They are asking acceleration. You get 1 meter per second square. Find the acceleration of 2 kg block. Okay. Apply the formula and give me the answer. Okay. One more question.
4.5 meter per second, sir.
4.5
meter per second.
1 minute, I will write. I want to know like what the acceleration. I can assume any direction. If I assume this direction like this, if you are not assuming, it will come automatically. AP is equal to A1 plus A2 by 2. What is the acceleration of pulley? 5. Up. Okay. A1 is going down, so it is minus A2 you need to find by 2.
Sir, I think I made a mistake.
11 meter per second square. Plus means what? It is going up.
I did +1 instead of -1.
No problem, no problem. You are learning, okay? When we are learning anything, we are making mistakes in starting. Clear?
Yes,
Write
sir.
one more question. This is a pulley. Here it is fixed. One block is there. This block is moving. Not moving. I just want the acceleration. Okay. It is 2 meter per second. Per second square. Find the acceleration of this block.
Acceleration is 2 meter per second, sir.
Let me check. See, the ends of the string. Apply the formula acceleration of pulley is equal to A1 plus A2 by. So pulley is going up with 2 meter per second square. I just write. Clear? A1 is what?
I assume that the 2 kg was good.
Okay, okay. See. Okay, okay. A1 is what? A1 you can check this fix. It is not moving, okay? Acceleration is 0.
So,
A2 will be 4 meter per second square. Plus 4. Plus 4 means? Clear?
yes, sir.
Understood?
Sir, I think I have been using this thing AP equals AM1 plus AM2 by 2. I didn't do A1 plus A2 by 2.
Okay. You can do one thing like here also. Just check how many ends are here. This is string. One end. One more end. Okay. On this pulley. This also like it is attached here. Okay. Start and end. Pulley is starting from here. Starting. String start from here on pulley and end here. Okay. Then how many? Like this. Clear? Now total work done by the string is 0. Net work. Now here tension will be like this. Here tension like this. String will apply tension on this. Here also tension like this. Tension. Is it correct? Clear?
Yes, sir.
Now if I ask like simple formula, net power supplied, work done, simply work done. Because of this, how much work? Force into displacement. It has no velocity. Clear? This check this. Check this. Here force is like this. Displacement is up. Clear? Then you should write force into velocity. Velocity is up, negative work done. Okay, clear? If you take, let us suppose, if you again differentiate velocity, it become acceleration. Okay, you can say like this also. Okay, similarly here, plus t minus 2, here t into 4 equal to 0. But you don't know na, here 4 I just find. You can take a2. Then t cancel, a2 will be 4. Okay,
Yes,
understood?
sir.
Because I just write now W is equal to force into displacement. When you divide by t, it becomes force into velocity. Clear?
Yes,
And
sir.
as per the question, this is if this is net power supplied, this is 0. Then I can say force into velocity, its sum is 0. Clear? Or I can
Yes,
say
sir.
this force into acceleration sum is 0. Or I can say like this, na? Clear?
Yes, sir.
But here, like you should, if you apply this concept, also you can get the answer. In every question, like previous question also, if you look at here, how many ends are here? One end, four ends. Clear? Apply the concept. Net work done by the string, okay, is 0. Then here on this 1 kg block, direction of tension will be like this. Okay, this 2 kg block, direction of tension will be like this. If you take us like pulley as a system, then tension will be like this. Okay, now check. Apply the concept. Here, work done how much? Force into displacement. Opposite. Clear? Plus. Force into displacement up. Again it is minus t into 5. Again minus t into 5. Clear? But here you don't
Yes,
know.
sir.
Plus t. Displacement I just assume in the up. T cancel. Clear? And what is the answer? Minus 1 minus 10 plus a2 equals 0. So a2 will be what? 11 meter per second square. Okay.
Yes, sir.
This work done by the string is you can apply this concept also. Okay. But I will give you one more trick. Okay. We always
Yes,
check
sir.
one string is connecting all the blocks. Okay. String must be continuous. And we check the ends. Clear?
Yes, sir.
What I have, like how many ends? Like always check ends. For example, this block. If somebody is asking like this, 1 kg string is there, 2 kg block. If this 2 kg block is going in the right with 4 meter per second square acceleration or 4 meter per second velocity, then what is the velocity of 1 kg block?
That is
Then
also 4 meter per second.
yes, then if you don't know this also, then apply the concept. String will
Yes,
apply
sir.
tension like this, here also tension like this, net work done, force into displacement. We need to find this. V1 will be 4 like this. How it is negative? Because force into displacement. String is going to displace in the right. Here this tension is in the left. Understood?
Yes, sir. Understood.
And one more thing, like, see, one more concept I will tell you. Previous question, like, If this pulley is going, let us suppose this pulley is going 2 meter per second square in the up, and these are the two blocks, block A, block B. I'm not giving mass,
Yes, sir.
and they are connected by the same string, like this string. Starting end, this is starting end. String start from here on the pulley, and it is going to end here. Then after that is connecting block B. Don't draw here, okay? Now, one more concept I'm saying. How many ends? This is the end which is connected with the pulley. One more end. Clear?
Yes, sir.
Now, over the whole pulley, I am telling again. I think in this question, like for example, this block is going up with a like if I say like 2 meter per second square. Then first find the acceleration of this B block. B. How will you find? Apply the formula. Acceleration of B. Acceleration of pulley is plus 2. Acceleration of A is 2 plus 2. A2. Acceleration of block B divided by 2. 2 2s are 4. You are saying 2. 2 meter per second square. You apply the concept. Now I am giving you one trick. Understand trick. Trick is that whether it is very complex question or that any difficult question. Trick is this. Take one string. One string is that one string is connecting both the blocks. How many ends are here? One end is here. This is connecting this A and B block. Now look at here. One by one. Check. When this 2 meter per second square, 2 meter per second square means this end is going up. Okay. Don't see other end. See this. When this block is going up, this length in between this point and this point, it is going to decrease. Okay. Then you should decrease means minus. Clear? Like this. Understood? Now forget rest of the end. Now see, look at this end. This end. When this pulley is going up with 2 meter per second square, this end is also going up. Clear? Don't see the rest of the things. What is given here, what is given, don't see. See, check only this. By moving this point, what is the effect on this length? Will this increase, decrease? If this pulley is moving up, then this point is also going up. When this is going up, this length is going to increase in between that. Okay? Clear? Then you should write plus 2. Increase means plus. Similarly, this end is also
Sir,
moving.
increase, right, sir? How will it increase, sir? If it's being pulled up.
If it is pulled up, then this end is also going up, na? If this pulley is going up, this end is also going up, na? Rest of the things is rest. This A is not moving, B is
Okay.
not moving. A is
Yes,
fixed,
sir.
B is fixed. Pulley is moving. Then length is going to increase, na? This pulley is moving, then this end is also moving up. Clear?
Yes, sir.
Trick I'm saying. Then you should write plus 2. Similarly here, plus 2, string length increase. Now for this block B, you can assume any direction. If you take direction of acceleration on this block is like this. A2. Clear? Now when this A2, this block, this end is going down with A2 acceleration, then length will increase. This length will increase from here to here. X1, X2 we have taken now. I'm talking about that.
Yes, sir.
Okay.
Yes, sir.
This length X1, X2 we have taken. I just wanted that because this X1, X2 depends on both pulley and block. That's why I have written relative concept. Okay, same thing I am writing here. Then it will be what? Plus A2. Then what is answer? A2 will be minus 2. Minus 2, why minus 2? Because you have assumed direction is down. It's trick. Clear? Again, tomorrow again I will bring many